Okay, so we start chapter 7, milk and dairy products. We already finished discussing the science part of milk, the properties, the components, the factors which influence milk composition, the synthesis, and so on, or the characteristics of milk, the microbiological aspects of milk and dairy products as well, physical properties as well. And then in chapter 6, we talk about the main processes which are applied in milk and dairy industry. And now we go to milk and dairy products. How do we combine the processes that we discussed in chapter 6 into a certain order to make a certain products? So because we already know the basic knowledge already, so now in this chapter we will not need to explain the principles again behind each step. Now we go to the first group, consumption milk. When we talk about milk products, mean the products which still have the liquid textures. The properties of the product is similar though of raw milk or the material. So it's called milk products. But dairy products mean the product which have now different texture, different characteristics compared to raw milk material, like cheese, like butter, those are dairy products. But liquid milk product is called milk products. And now we go to consumption, means a liquid milk product for consumption in the market. We have a number of products and they are classified based on the heat treatments that are applied to make the product. So we have pasteurized milk, we have sterilized milk, or UST milk. And we already discussed the advantages, disadvantages of each products, right? Pasteurization, sterilization, and UST, and so on. And then each of these can be further classified based on the fat content. So we have full fat milk, in which contain 3.5% of fat or above. Half fat milk contain from 1.5 to 1.8% of fat. And skim milk, then there is no requirement on fat content, of course, but it does still contain a little amount of fat, 0.05%, for example. Now, this is an illustration how to make pasteurized milk, consumption milk. We start from here, milk is pumped now. Of course, this is the pump. It's more accurate in volume if we pump milk from a tank rather than from a pipe. So they have a tank here. It's called buffering tank, balance tanks for pumping. Now we pump milk into the heat exchange. This is the plate heat exchanger to increase the milk to 45 degrees C. At this temperature, it is suitable to do cream separation. This is the centrifuge to separate now skim milk and cream. Now cream and skim milk is combined to a certain percentage of fat based on the fat content. Okay. And this is the surplus, the extra cream now. This is pumped out to make something else, maybe to make cream, to make butter, and so on. Here, now the cream is pumped here and part of the skim milk is mixed with the cream to go to pass through the homogenizer. Number 12, homogenizer. Homogenization is to reduce the size of fat globules to make the products more stable in terms of textures, in terms of prevention of creaming, right? To prevent the fat globules to rise up to the top, we need to reduce the size. We already discussed in chapter 6. Here we have to take part of skim milk back into the cream to have enough surface active material to cover the newly formed surface of fat globules. Because homogenization reduce the size of fat globule means increase the surface of fat globule. So we need more surface active material so that we need to mix here part of skim milk into the cream before homogenization. And then we bring the milk back to the heat exchanger to increase the temperature to the pasteurization temperature, for example, 76 degrees C. And then after a certain period, holding time, maybe 20 seconds, for example, or 15 seconds, and then the milk is now pumped back into the plate heat exchanger to cool it down. When we bring back like this, so we use output hot milk to heat up the input cold milk to save energy. We do like this, so we do one thing, but we have two purposes. One is to cool down the milk. Second is to heat up the input milk to save energy. Right? And this one is to illustrate how to make UHT milk. One side will be direct and the other side will be indirect UHT. On the right side you have direct UHT and here you have indirect UHT. The standardized milk which has been standardized on fat content already, now is heated up to 80 degrees C before UHT. For direct UHT, either we use steam injection or steam infusion. Look again chapter 6. And then we hold only for 2 seconds at this high temperature. And after that, steam injection is, we can increase the temperature of milk instantly, right? Very fast, like flash. And then we cool it down also very fast, flash cooling using the vacuum chamber. Direct expansion means you expand in the volume, then you reduce in pressure and the evaporation become very fast, and that give a cooling effect that cool down the milk very fast. And after that, homogenization in aseptic condition. Then the milk is cooled down to 20 degrees C and then pumped to the aseptic packaging chamber or to the buffering tank before packaging. But after this, everything should be in aseptic condition. After this, after the UHT. Now for indirect, to increase the temperature of milk, you need heat exchanger. For indirect, normally we homogenize the milk first before UHT. And before that, even the aeration step to remove the air to increase the heat exchange efficiency. If there is more air in the milk, then the heat transfer is not very good. That's why we remove the air. Also, when we remove the air, then we have better oxidative stability for the products. And then here we apply UHT 15 seconds, 142 degrees C. Then we cool it down. We also use heat exchanger to cool down. We use heat exchanger to heat up, hold, and then cool down. And then of course after UHT, the packaging should be in aseptic condition.